Hi guys, today I'm going to show you how to solve one-step equations. So that's the simplest form of equations, and let's have a look at an example. So if, for example, we have 7 is equal to x plus 5. So one thing that we need to think of when we're solving equations is that this side is equal to this side. So we need to think of it like a scale, like, you know, those old scales where you had something here and something here, and it always needs to be in equilibrium. Therefore, what we have to think of is that whenever we take something away from this side, let's say if we want to take out this round, let's say ball here, then to still, if I just take that off here, the scale will go down here. So I need to take out a ball here on this left hand side as well to keep this scale in equilibrium. And that's exactly the same thing with an equation. Whatever I do to one side of the equation, I also need to do it to the other side. So solving equations means that I want to have this x by itself. I need to know what this x is equal to. And yes, in this case, you can see that straight away. However, I still want to show you how to solve this step by step. So in order to have the x on its own, I need to get rid of that 5 here. So I need to take, I'm going to write this with a different color. I want to take away 5. I want to take this away. Now, as I said before, we need to keep that scale in equilibrium. So what I do to the right-hand side, I also need to do that to the left-hand side. Okay? So if I take away, my 5 from 5, this is a 0 term. With your algebra tiles, this would be representing a 0 term. So 5 take away 5 gives us 0. That's gone. 7 take away 5 gives us 2. So 2 is equal to x because that 5 is gone. And that's my answer here to this question. Now we can look at this with other operations as well, not only plus. So if, for example, I have 8 is equal to a minus 2. Okay. I want to have the a on its own on the right-hand side. So I want to get rid of that negative 2. And that's where that term inverse operation or opposite comes into play. So to get this to 0, I want this gone, I need to add 2. That's what I'm going to write here. I need to add 2 to get a 0 term here. Now I can't do that just to one side. I also need to do it to the other side. So I get here, plus 2 on this side as well. So 8 plus 2 gives me 10. And on this side, I'm left with my a because negative 2 plus 2 gives me 0. The opposite of negative 2 is positive 2. The inverse operation of minus is plus. So I'm adding 2 here. So let's have a look at another example. If, let's say, I had 10 is equal to 5a. Now here it becomes a bit more tricky in terms of what's the operation between my 5 and the a? You need to remember from last chapter, from last unit, that 5a is the same as 5 times a. Yeah? The inverse or the opposite of times, the inverse of times is divide. So to get rid of that 5 here, I need to divide by 5. Okay? What I do to one side, I also need to do to the other side. So on my left-hand side, I have here 10 divided by 5, 10 divided by 5, giving me 2. 5 divided by 5 is 1, so that gives me 1a, so a is equal to 2. If you were representing this with algebra tiles, you would have to divide these 10 units into 5 equal parts, and that would give you 2 as well, just as something to visualize this with. Please also watch the video on how to use algebra tiles for solving equations. It does really help a lot. So finally, we're going to have another one. 6 is equal to, let's say, x over 2. Now, this fraction line is the same as a division. So inverse operation would be multiply. Opposite of dividing is multiplying. So to get rid of my 2 here, it says divided by 2. The inverse or the opposite would be multiply by 2. Whatever I do on this side, I also need to do on this side. 6 times 2 gives me 12. Sorry. 6 times 2 is 12. And now this is gone because divided by 2 multiplied by 2 is simply times 1. So that gives you the x here. Or I could also put it that way. So just as a side note, I'm just going to make that a gray writing so that you're not getting confused, hopefully. So if I have x divided by 2 and then multiply it by 2, this is actually fairly the same as 2 over 1. So if I simplify that, I can cross out these 2 here, and I would just be left with x. Just a short revision on working with fractions. And that's it for the one-step equation. So you should be good to go on these on